In this video lecture, we are interested to know sets, real numbers, and numerical expressions as the basic mathematics and introduction to mathematics for a zoologist. So in mathematics, we use symbols used as 6, 2 by 3, 0.27, and pi to represent numbers. The symbols plus, minus, multiplication, and division commonly indicate the basic operations of addition, subtraction, multiplication, and division, respectively. Thus, we can form specific numeral expression. For example, we can write the indicated sum of 6 and 8 as 6 plus 8. In contrast with the numerical expression, there are algebraic expression. What's the difference between numerical expression and algebraic expression is that in numerical expression, we only use numbers, but in algebraic expression, we use variables. So instead of numbers here, we use variables x plus y. The x and y in such an expression are called variables. Variables mean which change the values, which can hold the value, different values, and the phrase x plus y is called an algebraic expression. We can formulate these expressions in the form of table. So in the table, if operation is the addition, in numerical expression we can write as, for example, 4 plus 6, but in algebraic expression we can write as x plus y, and we called it the sum of x and y. Similarly, for subtraction, for the numerical expression we write 14 minus 10, and for algebraic expression we write a minus b. And for multiplication, we write 7 multiplied by 5 or 7 multiplied by 5. Similarly, for algebraic, we can multiply two variables a and b. We can also write as a into b and a into b like this, or ab, or simply ab. The product of a and b, and for the division with the numbers, we can write 8 divided by 4 or 8 by 4 or 8 divided by 4. So in contrast, using variables, we write x divided by y, x by y, or x divided by y. So here is, we can say it's the quotient of x and y. Note the different ways to indicate a product, including the use of parentheses. The AB form is the simplest and probably the most widely used form. Expressions such as ABC, 6xy, and 14xyz all indicate multiplications. Where we use sets, so there are three forms to write a set. A set is collection of objects, and the objects are called elements of the set or members of the set. In arithmetic and algebra, the elements of a set are usually numbers. The use of set braces to enclose the elements or a description of the elements and the example. For example, we can represent a set A which consists of the vowels of the alphabet in any of the following ways. The first is the word description form, in which we can write a statement that is set of vowels of alphabets. And next is the list or roster description. Here we can say that A is equal to a list of A, E, I, O, U, the list of all vowels. Third form is the set builder notation, where we use the mathematical symbols. That is, a set A consists of elements x such that x is a vowel. If the number of elements is quite large, for example, all of the letters of the alphabets can be listed as A, B, C, so on, Z. We simply begin by writing enough elements to establish a pattern. Then the three dots indicate that the set continues in that pattern. The final entry indicates the last element of the pattern. For example, if the set contains 1, 2, 3, so on, the set begins with the counting numbers 1, 2, and 3. The three dots indicate that it continues in a like manner forever. There is no last element. A set that consists of no element is called the null set, written as phi. Set builder notation combines the use of braces and the concept of a variable. For example, x such that x is a vowel is read the set of all x such that x is a vowel. Note that the vertical line is read such that we can use set builder notation to describe the set 1, 2, 3, so on as x such that x greater than 0 and x is a whole number. We use the symbol epsilon to denote set membership. Thus, if A is equal to AEIOU, we can write E belong to A, which we read as E is an element of A. The slash symbol is commonly used in mathematics as a negation symbol. For example, M does not belong to A. We read as M does not belong to A. Okay. M is not an element of A. Two sets are said to be equal. Two sets are said to be equal if they contain exactly the same elements. For example, 1, 2, 3 is equal to 2, 1, 3. Because both sets contain the same element, the order in which the elements are written doesn't matter. The slash mark through the quantity symbol denotes, through the equality symbol denotes, is not equal to. Thus, if A is equal to 1, 2, 3 and B is equal to 1, 3, 2, 3, 4, we can write A is not equal to B, which we read as set A is not equal to set B. Next is the real numbers. So we refer to most of the algebra that we will study in this text as the algebra of real numbers. This simply means that the variables represent real numbers. Therefore, it is necessary for us to be familiar with the various terms that are used to classify different types of real numbers. So the numbers 1, 2, 3, 4 are called natural numbers. Counting numbers are positive integers. If we include 0 in natural numbers, we will get whole numbers or non-negative integers. And if we include only negative numbers, minus 1, minus 2, minus 3, we called it negative integers. And if we include 0 in negative integers, we can say non-negative integers. And if we combine these negative integers and non-negative integers and positive integers or natural number, we will have a set of integers. So set of integers include non-negative integers and natural numbers. Or we can say the set of integers include negative integers, positive integers, and 0. We define rational number as follows. So what is the rational number? A rational number is any number that can be written in the form a by b, where a and b are integers and b does not equal 0. So to write a rational number, we just have to pick two integers, any two integers, and we have to write in the form of quotient. So take two integers, the first is -3 and the other is 4. So then write in the quotient form and you will get the rational number. Similarly, here are two positive integers, that is 2 and 3. If we write in the quotient form, we will get rational number. In a similar way, 15 is a positive integer, 4 is a positive integer. We write in the quotient form and we will get a rational number. Same as with 1 over -5. Our numbers such as -4, 0, 0.3 and 6 by 6 and a half are also rational numbers. All of these numbers could be written in the form a by b as follows. -4 can be written as -4 by 1 or 4 over -1. 0 can be written as 0 over 1, 0 over 2, 0, 3. 0.3 can be written as 3 by 10. 6 and a half can be written as 13 over 2. So we can also define a rational number in terms of decimal representation. We classify decimal as terminating, repeating, or non-repeating. So what is the terminating? The terminating decimal ends, for example, 0.3, 0.46, 0.6234, 1.25, because after the decimal point, there are countable numbers. So we can count that 1, 2, 3, 4, 2, 5, 3. And repeating in the repeating numbers, after the decimal point, the same number or the group of numbers, group of decimals are repeating digits. For example, 1, 4, 1, 4, 1, 4, 6, 9, 4, 6, 9, 4, 6, 9, 4, or the 1, 7, 1, 7. So the a digit is repeating or the group of digits are repeating. So we can say that this is the fractional part is repeating. And non-repeating is, for example, if we just focus on this number 3.14159265535, it's a value of pi, that is 22 by 7. So there is the numbers are not repeating in a sequence, not a group of numbers not repeating in a sequence. The same is with this number and the other number. So the fractional part of this number is not repeating, okay, and not even terminating. So then we can define a repeating decimal as a block of digits that can be any number of digits and may or may not begin immediately after the decimal point. A small horizontal bar is commonly used to indicate the repeat block. Thus, 0.666 can be written as zero point 0.6 bar and 0.23171717 is written as 0.2317 bar. In terms of decimals, we define a rational number as a number that has a terminating or a repeating decimal representation. The following example illustrates some rational numbers written in A by B form and in decimal form. So 3 by 4 can be written as 0.75, 3 by 11 can be written as 0.27 bar, 1 by 8 can be written as 0.125, 1 by 7 can be written 0.142857. We define an irrational number as a number that cannot be expressed in A by B form, where A and B are integers and B is not zero. Furthermore, an irrational number has a non-repeating, non-terminating decimal representation. So these are irrational number 3.14, 1.4142, 0.276. These are irrational numbers. And some example irrational number are here. Square root of 2 is an irrational number, square root of 3 irrational number, and pi is irrational number. A set of real number is actually composed of the rational numbers along with the irrational numbers. So every real number is either a rational number or an irrational number. So we can explain with the following diagram. Real number have a two kind of numbers in it, rational numbers and irrational numbers. Then rational number has two further kind, integers, non-integers. In integer there are positive integers, negative and zero. Similarly, non-integer there are minus and positive and negative. And in irrational number, there are positive irrational and negative irrational number. We can trace any real number down through the diagram as follows. 7 is a real, rational, and integer and positive. Minus 2 by 3 is a real, rational, non-negative, and negative, non-integer and negative. Square root of 7 is a real, irrational, and positive. 0.38 is real, rational, non-integer and positive. Remark, we usually refer to the set of non-negative integers as the set of whole numbers, and we refer to the set of positive integer as the set of natural numbers. So the set of positive integers and set of natural numbers is the same thing. And set of whole numbers and non-negative integers and set of whole number is the same thing. Set of whole numbers differs from the set of natural number by the inclusion of only zero. Concept of subset is convenient to discuss at the time. At this time, a set A set A is subset of set B if and only if every element of A is also an element of B. So this is written as A is a subset of B and read as A is a subset of B. For example, if A is equal to 1, 2, 3 and B equal to 1, 2, 3, 5, 9, then A is a subset of B. So similarly, we can give an example that the set of whole numbers is a subset of the set of integers. It's a bigger diagram. For example, real number includes two main numbers, rational and irrational. In irrational, there are then integers and then whole numbers, then natural numbers. So natural numbers, whole numbers, integers, rational and irrational are actually the real numbers and are the part of the real numbers. Okay. So the set of integers is a subset of the set of rational numbers. The set of rational number is a subset of the set of real numbers. So it's not difficult to understand. Okay, what is the set of rational numbers and what is the set of integers, whole numbers, natural numbers. So it's not a difficult task to understand.